Okay, so now we're going to look at constructions. There are a lot of different types of constructions we've got to know for this, so this video will be quite long. So if you think you know the basic ones, then just whiz through, stop and start the video where you feel it's appropriate, and I'll do the C-grade question type bearings, constructions with perpendicular bisectors and angle bisectors towards the end of the video. So I'm going to start off with some basic constructions first. So it's telling me here that I've got to construct this triangle accurately, so they're telling me here by that keyword I'm going to have to use rulers, compasses, and if there was angles involved, then protractors. So we're going to show all the construction lines. Really important then that we leave all our construction lines on, do not rub anything out. So let's have a look at our first instruction. They're telling us to draw the bottom of this triangle as 6.3 centimeters. So that bit we could do with a ruler, and so we measure 6.3 centimeters. So 6.3. So that's that bit done. It then wants us to draw two lines, one at 5.7 and one at 4.2, but they haven't told us an angle, so it's very difficult to judge that. So this suggests that our compasses will be useful here. So we get a compass, and the first line we know has got to be 5.7 centimeters. So if we open our compasses up at 5.7 and put it at the left hand edge, because the 5.7 is coming from there, then again we're not sure where it's going to be, so the key thing here is that we just draw an arc fairly long, which we hope the other line will be able to cross with it. So we're told the other one's 4.2, so if we put 4.2 and get our compass, so we know that it's from the other end of the line, the bottom line, so we literally get our compass and we've now got where the two arcs cross. So once we've got that, we simply make sure we're lining up our ruler with the arcs carefully, and do the same the other side, line it up really carefully, and then we can do a double check, just check it through. So this one was supposed to be 5.7, yep, and this one's supposed to be 4.2, yep. So that's fine. So that's how we can construct a triangle with three given lengths, basically called a side-side-side triangle, using a ruler to get the first line, and then compasses to get the positions of the other two lines where they meet at the two arcs. Another type of question they ask you to do on constructions is to draw a triangle accurately again, but this time they've given us an angle to work with, and they're telling us here that they've actually drawn one of the lines for us, so they've actually drawn the line AC already. So what we need to do is use that and then work out the other bits we need. So they're telling us we've got an angle of 38 degrees. So because it's about accurate drawing, again they've mentioned that word accurately, then we need to be using our protractor. So we line up the centre of the protractor with the end of the line at C, because that's where the angle of 38 degrees is. Our 0 is on the outside of the protractor, and we always count up 10, 20 and so forth on a protractor anyway, so we look at the scale that works like that. So 10, 20, 38. So again, being really careful, put a mark down at 38 degrees, and we've been told that this line is 7.3 centimeters long. So what I tend to do is put 7.3 on the end, line up, so I can then just go to 0, and we'll do a double check. 7.3, yep, just finish that line off. So that's the 7.3 centimeters that was on the original triangle. The 8 centimeters was given to us, so literally we now just join up to finish off the triangle. The question goes on and says measure the size of angle A. So they've shown you that the angle at A is this one here, so they're asking us to measure this angle. So again, measuring, get our protractor, and again line up a 0 with one of the sides in terms of one of the lines. So my 0 is here. This time my 0 is on the inside scale, so I'm counting round 10, 20, 30, 40, 50, 60, 64 and a bit, so 65. We're allowed to be 2 degrees out, so it's 64, 65. So 65 degrees would be the answer for that one. If I wanted to do a check, then of course I know that that one was 38 degrees, we've measured this one as 65 degrees, 180, take away the 38 degrees, take away the 65 degrees, so 60, 90, 98, 103, 77, so this one should be 77 degrees as a check. So we could check it, just do a final thing, so get our protractor, line it up. Our inside angle goes 10, 20, 30, 40, 50, 60, 70, come round 77, so fairly good, 77 degrees. So again, that's how we would construct a triangle given an angle and two lengths. Again, this would be known as a side angle side triangle, and we use a protractor and ruler to do that using the line that they gave us. Another type of construction is where they say to us, use the ruler and compasses to construct an equilateral triangle with side lengths of 6. They're telling us they've already drawn one of the lines, so 6 centimeters, not quite, so obviously the photocopying has enlarged that, but the principle is the same. So you assume, if you measure carefully, that it was the 6 centimeters, which it should be in the proper exam. It's just a photocopy that's enlarged this one. So you need to open your compasses at the same length as the line they give you, and you know that you need all the sides to be the same length. So in using the same length as the line, then we're going to ensure that by then getting our two cross points, and we then join that together from the end of the line to where the two arcs cross, again being fairly careful to make sure it's accurate. Don't want to lose an easy mark in the exam by just being a bit slap happy. So one equilateral triangle, we check it of course by measuring the angle, and we know that the angles in an equilateral triangle should all be 60 degrees. So again, with this protractor, the inside angle is where the 0 is, so it's 10, 20, 30, 40, 50, 60 degrees, just as we would like it to be for an equilateral triangle. Another construction that they expect you to be able to do in the exam is to draw a perpendicular bisector. Now, the idea of a bisector is it cuts the line in half and it's perpendicular, so it makes a right angle. So that's what we need to be able to construct using our compasses. So the idea is as a compass construction, which simply get your compasses and you open them up over half the distance. I tend to go for about 3/4 of the distance between the 2 points, and you draw roughly a large part of the arc of a full circle over halfway, so it's over the halfway point that you recognise. Keeping the compasses the same distance, you then get the compass at the other end, and you don't need to draw the full arc this time. You literally just get such that you can cross over the arc that you drew in the first case. In doing that, you've then got the 2 cross points, which I tend to put little dots on to help me line my ruler up, so where the 2 arcs are crossed. I then get my ruler and draw the line through that point. Now, the special thing about the perpendicular bisector is it allows us to see where the boundary is between 2 points. So these could be 2 towns, and it might be we want to know the halfway mark, so that where we're always nearer to one town than another. So anything this side would be nearer to A, anything this side of the line would be nearer to that. Any point on this perpendicular bisector is exactly the same distance from both positions. So for example, if I just choose a random point there, if I measured it, I would find that that's 6.2, and if I measured it from the other side, then I should find it's identical, which it is, 6.2. So that's the idea of a perpendicular bisector. So opening compasses are over half the distance between the 2 points. Say I tend to go for 3/4 of the way. I draw a fairly big arc of the circle first, then from the other side I just draw the cross points of the 2, so the 2 arcs cross over each other to know where I line up my ruler to draw the centre, and then we've got our perpendicular bisector. Cut the line exactly in half at a right angle. Another construction that we need to be able to do for our exams is where the question says construct the bisector of an angle. So in other words, we're now going to be thinking about cutting an angle in half and drawing the bisector of it. So the way we do that is we get our compasses again, and we don't need to have our compasses open any particular distance, it's just so they're really comfortable, so somewhere like that. And literally we draw an arc through the two lines that make the angle, and where those two arcs cross, sorry, where the arc crosses the two lines, we then keep our compasses the same distance and draw another arc roughly where we think the middle of the line, the middle of the angle is going to be, and then from the other side we then do the same. Where the arc crossed the line, we then draw another arc where the two arcs are crossed. Again, I tend to get my pen point just to kind of make a mark where the two arcs crossed so I can line up, and I get my ruler and then very carefully draw through. Now if we've done that perfectly right, our check would be that we measure the original angle, and in this case the original angle was 10, 20, 30, 40, 56 degrees, so we'd expect our bisector to be 28 degrees, which it is. So that's how we could check the angle bisector has been drawn properly. But I say, literally, to draw an angle bisector, we put the compass point at the angle where the vertex of the two lines meet, and we draw an arc through the two lines, and where those cross points are, we then draw a little arc, draw another little arc, and where they two cross, that's going to be the point to connect to draw our angle bisector. Another construction you're expected to be able to do is to draw some given angles, some special angles, just using compasses and a ruler. Be careful here, it does say ruler and compasses, so don't be tempted to get a protractor to actually draw the angle. Yes, use a protractor at the end to check it's close enough to 45 to get the marks, but you must draw with compasses and leave your construction lines. Again, they give you a hint here, always leave your construction lines. So we recognise 45 degrees is a half of a right angle, so what we want to happen is we need a right angle somehow, and then we can draw the angle bisector by cutting our arcs, do our arcs across, and then where they can meet, that'll give us our 45 degrees. So we need to create a right angle. Well, we saw earlier in the video that to draw a perpendicular bisector, it does create a right angle where the line crosses. So what I tend to do is I tend to want to have A as my centre of a perpendicular bisector, so I tend to extend the original line, and then I put my compass at a comfortable distance at A. I cross over the line. That has made A the centre of those two cross arcs. That means if I draw a perpendicular bisector between those two arcs, then A must be exactly in the middle at a right angle. So again, the way we draw a perpendicular bisector, open the compass about 3/4 of the way between the 2 points, draw a fairly big arc for the first bit above the A and below the A, and in this case we can then draw our two cross arcs. That then allows me to put my pen point down between the two arcs just to line up carefully. That has given me my 90-degree angle, so now I can just draw a perpendicular, sorry not perpendicular, an angle bisector for these 90-degree angle. And again, just to get my compasses at a comfortable distance, so cross the two lines that create the 90 degrees, get my compass at the two cross points and draw roughly where I think the middle is, again at the other side. That then allows me to get my point where I can connect the angle and that should be the angle bisector. And again, this is the only time you use a protractor for this kind of question, is you actually get your protractor just to check that it was 45 degrees. So 10, 20, 30, 40, 45 degrees. So that's one construction we need to be able to do, to be able to create a 45-degree angle by bisecting a 90-degree angle. This next question is asking us to create a 30-degree angle. Well, again, we recognise that if we had an equilateral triangle, that would give us 60 degrees. So if I halve that by bisecting that angle, then I will create my 30 degrees. So they've given us a line already drawn. So to create a 60-degree angle, I'm going to draw an equilateral triangle. So I make sure my compass is the same length as the line, and then draw roughly above the middle of the line an arc, put my compass point at the other end, draw the arc so it crosses. Where the two arcs cross, just put a little dot, help me to line my ruler up, Now I don't have to complete the full triangle for this, but I just like to do it so I can see that I am drawing a 60-degree angle. I could have just drawn that line there because that would have then created a 60-degree angle. So I now know that that angle down there is 60 degrees. So if I bisect that by using the construction of bisecting an angle, so again the two lines that made the 60-degree angle were those two, so draw an arc through both, get my compass to connect with that arc point, draw another arc, do the same the other side where I created that line, make sure the two arcs cross each other, put my dot, line it up with the angle I'm bisecting, the 60-degree angle, and again this is the only stage you use a protractor, is to check that it was 30 degrees, which is what the question wanted. So we can see 10, 20, 30, so we did draw a 30-degree angle. So that's how you can construct a 30-degree angle, by drawing an equilateral triangle first and then bisecting that angle. Now other types of constructions that you're expected to know for your exam are to be able to draw a perpendicular through any point they give you on the line. Now one way of doing that is to make P the centre of 2 points. Well, we've already got B, so it would be reasonable to open my compasses up the same distance to B, then come to the other side. That has made sure then that P is at the centre of those two arcs. That means if I draw a perpendicular bisector between those two arcs, then it will be a right angle going through, a perpendicular line going through the point P. So again, tend to open my compass about 3/4 of the way between the 2 points, draw a fairly big arc the first time round. On the other side I can then draw the arcs that cross the first arc. Put my 2 dots down where the 2 arcs crossed so I can line my ruler up, and if I've done that carefully enough, then I've now drawn the 90-degree angle through the point P as requested. This next question says, use a ruler and compass to construct the line from the point P that is perpendicular to the line AB. So in other words, I want to be able to get it to the stage where I've drawn a line that's 90 degrees between the A and the B. Now a little trick for this one, we literally open our compasses up so that it's over the length of the line, and we literally draw such that we get 2 arcs that cross the line, keeping our compasses the same distance. We then draw 2 arcs the other side, and we can literally just join P, put the dot down with the 2 arcs crossed. We can literally draw P down to that, and that has drawn a perpendicular line straight down from P through that line, and we can check it with our protractor just to make sure. So line that up 90 degrees, so that works quite nice. So that's a way of drawing a perpendicular line from any point through a line. So we open our compasses up, made 2 arcs through the line, same distance, 2 arcs, join up. Another construction that they expect you to do is work with a topic called loci, the locus of points, and this is where we've got to interpret the words to decide what do they want us to do. So we really need to remember that if we have a single point, then the idea of loci, the path of objects, is we want to show all the points that are equidistant from there. So in other words, it's going to create a circle. So a single point in a question tends to always mean draw a circle, or part of a circle if it's inside a given restriction. If they mention 2 points, so say A and B, and they want the points that are nearer to B than A, or they want the points equidistant between the 2 points, then 2 points will always mean draw a perpendicular bisector. So that's where the compass point over halfway, draw your arc, draw the 2 arcs that cross, and then draw the line between. Anything this side closer to A, anything that side closer to B, anything on the line equidistant, the same distance from both points. Other things that they expect you to be able to do, well, this question talks about closer to the line AC than the line AB. So if they mention two lines in a question, well, two lines create an angle where they meet. They're always then asking you to draw the angle bisector, so the one where you do the arcs through the two lines and then get your compass and draw the two arcs that cross roughly in the middle of the angle and then join it together. So two lines being asked for, then we end up drawing a angle bisector. We'll see later on the other type of question that they ask. There's only four types technically that they ask in exams. So let's have a look. So we've got to do 4 centimeters from the point B. So it's a single point they mentioned there, point B. So they're asking us to draw a circle or part of a circle. So we get our compasses and ruler, and we open our compasses up 4 centimeters, as the question says. Don't get caught out by the fact that it says less than 4 centimeters, because you're not asking you to open your compasses up less than 4 centimeters. They mean draw it at 4 centimeters, and then anything that is inside that circle will count for this region. It will count for the condition they've given you here. Because they're talking about shade the region inside the triangle, then I'm not going to draw the full circle. I'm literally just going to draw the 4 centimeter arc. So what this is telling us so far then is that we're going to shade the region less than 4 centimeters from the point B. Would mean that we'd actually shade all of that, but we won't do that yet because there's a second condition. They're telling us to and do something else. So they're telling us we want to be closer to the line AC than the line AB. So AB and AC create an angle. I'm going to have to draw an angle bisector then to decide on where the boundary is, where I'd be closer to this line or closer to that line. So to draw an angle bisector, just open our compasses up a comfortable distance, put them on the point A because that's where the two lines meet, and we draw our arcs through the two lines, get our compasses keeping the same distance, draw our arcs roughly in the middle of where we think the angle is going to be bisected, and make sure we've got a cross point, dot to line up. So line up our dot with our angle. So we now know that the boundary for being closer to AB is this side, closer to AC that side. Any point on this is exactly the same distance from those two lines. So now we can actually do the final part of the question. It says shade the region inside the triangle, which is less than 4 centimeters, but it's also closer to the line AC. So in other words, we have to be this side. So they're asking us to shade in this part of the diagram. Anything this side of there is less than 4 centimeters from B, but anything that side of the line is closer to the AC because that's the boundary line. So that's how we would do that kind of question. Another kind of question is the one where they give you a single line, and if they give you a single line, then they're always implying draw a parallel line. So we saw a moment ago that if we have a single point in the question, so like the point B, then we draw a circle or part of a circle. If they talk about 2 points, A and B, then we're going to draw a perpendicular bisector between them to know the boundary line. And if they mention 2 lines, then we're going to draw an angle bisector because the 2 lines will meet and create an angle, and we want to be halfway between to know the boundary. And now we've got the situation where we've got a single line and they want us to draw the locus, so the path of all the points that are exactly 3 centimeters from the line PQ. So one way to do this is to get your ruler, turn the exam paper around maybe because it makes it really easier to kind of get your ruler lined up, and we're going to do 3 centimeters either side, so 3 and 6, and do that at 3 points to make sure we can line our ruler up carefully. Again, do our measuring carefully. So 3 centimeters that side, 3 centimeters that side. So we know that our line's going to be parallel to here. So we draw. Now we've got to be a little bit careful here because once we get beyond this point here, we're actually getting further than 3 centimeters away. So what we have to realize is that the end of each line is actually a fixed point. When you've got a fixed point, then we always draw a circle or part of a circle. So they said to do it 3 centimeters, so we open our compasses at 3 centimeters. So we've done that, and we put our compass point down, and we draw, at this stage it will be half a circle, and then we go to the other end and we draw again half a circle. And now we can complete the diagram, because we can now line up our ruler with the 3 points we drew before and join up the 2 ends of the half circles. So this is one of those classic ones where it looks just like a racing track. 3 centimeters away from a single line parallel. Anything this side of the line is 3 centimeters or less. Anything outside is more than 3 centimeters away. Another kind of question they ask on the use of locus and the path of points is where they say to you, draw the locus of all the points that are equidistant. Now, fancy word, but it literally just means equal distance. So equidistance means equal distance. And it's talking about 2 points. So what we've got to realise in this topic area of constructions and loci is that when they mention 2 points in an exam question, then they're implying to draw a perpendicular bisector between those 2 points, so you know where the boundary is. That's equidistant. So to draw a perpendicular bisector, we get our compass and we make sure that it's roughly around 3/4 of the way. It's over halfway, but I used to use 3/4. Draw a good part of the circle on one point, and then from the other point we just need to know where it crosses that first one. So I draw 2 little arcs where the cross goes. Where the 2 arcs have crossed, they're my construction points to then draw a straight line down between those 2 points. And what that's done is, if we imagine joining A and B together, then we've created a perpendicular line that's cut the line AB in half, so that's the bisector perpendicular at right angles. So we have our points which are equidistant. Any point on this line to check should be exactly the same distance. So 4.2, and then from the other side, slightly over. That means I've been slightly inaccurate, and I can see here that I probably went slightly over to the right, so that would mean rub that out and move it over. So something to check, always do that. Okay, so that was a summary of all the things that you're expected to know about constructions. A long video, but lots of things for you to know. Hope you get some